started recording. And yeah, I guess let's just get right into it. Um, First problem, I believe, is okay. So we could probably do these in like 10 minutes. So a woman makes 50% more than husband. Let me use a smaller fonts. Can you see my screen?
Yeah.
50% more than husband. Go feminism. Okay, so let's say that the husband makes H, then the woman makes 1.5H. So what? Basically, these get added together. So this is H plus 1.5H is equal to 2500. Uh, yeah. So what is this? 2.5H is equal to 2500. And then just divide through, so H is equal to 1000. 1.5H is the wife's salary, and that should be 1500. Right? So just as a sanity check, these two things do add up to 2500. And this one is 50% more than the other one. Sound good? Question 2. It approaches a red stoplight at, what is this, 5 meters a second? The light turns green as the car reaches the traffic light. So the car accelerates at... Oh, by the way, what exactly is this? Is this a practice exam? Hello? Just double checking. This is a practice exam? Okay. All right, just making sure I'm not...
This is a practice exam.
All right, just making sure I'm not giving out something I'm not supposed to. But, okay, its car approaches a red stoplight at 5 meters a second, and the light turns green as it reaches the traffic light. So it's basically saying, right as the car reaches this point, its initial velocity was 5 meters a second, and right at that point, it starts accelerating. Right at that point, the acceleration becomes 2 meters a second squared. And you're asked, how far will the car go in 5 seconds? So with this situation, it's the kinematic equation we want to use is the one for displacement. So this is just v naught t plus 1/2 a t squared. So just know your 4 kinematic equations by heart, please. 2 of them are, I think, the really simple ones. But then the 2, I think they're just like velocity is equal to change in velocity is acceleration times time. And what's the other one? Like total distance is velocity initial plus velocity final over 2 times time. But this one and the vf squared minus v naught squared is equal to 2ax are sort of the 2 more complicated kinematic equations. And most problems will use one or the other. This particular problem, since we don't we care about time and don't really care about the because we're given time, but not the velocity final, we want to use this equation. So we just plug it right in. It turns into 5 times 5 plus 1/2
Is this
to...
the practice midterm? Because this looks very easy.
Yeah, that's this is what I've been told is the practice midterm. Right? I agree, it is very easy. It's a single equation.
Wow. I wish.
Huh?
I wish they were all like this.
Yeah, I guess as a point of comparison, okay, the next one is 70% sand. So the mixture that desired is 70% sand and 30% cement. When I was in physics my freshman year, I feel like, the systems of equations problems that are typical on the homework 4 long were pretty much the baseline that would get introduced to us in lecture. And the actual problems we would get assigned were challenge problems that would take all weekend to solve. Sand and 20% cement. So what? This is what he has, right? 14 kilograms of this stuff. And he wants to dilute it into 30% sand, 30% cement by adding in more cement. So this is basically saying, okay, how much of each does he actually have? So that's 0.8 times 1400 kilograms. This is how much sand he has. And 0.2 times 1400 kilograms is how much cement he actually has. Right? So we actually want to multiply these numbers out. Gosh, I should be able to do this in my head. What does this turn into? 280? This one's 280, I think. So then this one must be...
And the top is 1120.
1120, sounds good. kilograms and kilograms. So then at this point, you're considering ramping up the cements until this value becomes gets reduced from 80% to 70%. So one way to think about it is 1120 divided by 1400 plus x. So x is the number of kilograms of cement he's going to add, needs to become 0.8, right? So you can multiply this to the other side. Does this make sense? Multiply this to the other side and just be able to solve that. 1220 is equal to no, excuse me. We want this to be 0.7. We want this to be 0.7, right? That's the target.
Okay, that's what I thought.
Otherwise, it doesn't make sense because we were getting things to cancel. So 1,100, or was this 0.7x? So then this should look like this is 0.8 times 1400, so this just turns into, I think, 140 is equal to 0.7x. And then I think you just divide that through to get your x. So do you get a calculator for this, by the way?
You do.
Yeah, we get a calculator for this.
Okay, that's not too bad then. But this looks like 20. So 200 is equal to x. So what is this saying? This sounds to me like you have to add 200 kilograms so that you end up with 480 and of cements and 1,120 of sand. Right? So if you add these together, what do you get? You get 1,600. So a total of 1,600. And yeah, that seems about right. So then 0.3 is the cement and 0.7 is the sand. Okay. Do you all know how to read a graph? You all know the acceleration is a derivative of velocity, which is a derivative of position. But if it's asking you the velocity of an object moving in one dimension, what is the average velocity between 3 and 4 seconds? Well, because it's a nice straight line, this means you can just read off whatever it is at 3 and whatever it is at 4, and you can just average them. Right? So it looks like if this is 1 and this is 2, you can just average them to get 1.5. Yeah? It's this only works because it's a straight line. If it wasn't a straight line, you would have to use integration, which is a little bit nastier, and I don't think you've been introduced to it yet.
Wait, sorry about that. Wouldn't it be 1 meter second, or am I doing it wrong? Because 2 minus 1 is 1, and then 4 minus 3 is 1, so...
You're talking about slope.
Oh, okay. Okay.
Right. Let me see if I read the question wrong. So this graph itself is velocity, right? Velocity versus time.
Mm-hmm.
And it's asking you about average velocity between 3 and 4. So yeah, you're asked to just find the midway point. What you calculated there was the acceleration over the period.
Oh,
right.
Okay.
You found slope.
Got it. Thank you.
Sure. Okay, so then the next one is exactly what they're asking. What's up?
Sorry. How did you get 1.5?
We're just, you basically take the velocity at 3, which is 1, and the velocity at 4, which is 2, and you just have to average them to get 1.5.
Oh, I see.
So, it's the total distance over the total time?
Well, I mean, that is what velocity is, but from the chart, that equation, what you just described isn't going to help us because the chart itself says velocity, right?
Yeah.
So we know the velocity at 3 seconds, and we know the velocity at 2 seconds, and we're asked for the average over this period. So we just have to average the endpoints together.
Oh, okay.
Yeah. It's like if you're saying, you're accelerating at a constant rate, and at the start you're at 0. Your velocity is 0 meters a second. At the end, you're 10 meters a second. Your average over that period is 5 meters a second, right? It's yeah, this isn't calculus. This is just a average. So the next part is asking, what is the acceleration between 0 and 2 seconds? 0 and 2. And yes, at this point, you're being asked to find the slope, right? Because the derivative of velocity is acceleration, and the derivative is also just basically reading off the slope of the graph. And it looks to me like the slope is just from 0 to 2, right? 0 to 2. And I think this value goes from -2 to 0. So don't be fooled by the fact that this number is negative. The fact is we're still trying to look for the slope, which is just 2 over 2, which is 1. The slope is 1. Slope is equal to acceleration is equal to 1. Okay? And
I have a question.
Sure.
So say you're given the position graph and you're asked for average velocity. Would you do from like say T2 to T7, would you do the value of the position at T7 minus the value of the position at T2 all over the time?
Yeah, so sorry, you were saying if you were given distance, or I guess x versus t, right? Assuming it's a linear or a constant function, then yeah, that works fine. So you're saying the time between 2 and 7, right? And whatever these positions are? Yeah.
Yeah.
Actually, forget what I said. It doesn't need to be linear. To get the average velocity, yeah, you would just take whatever this height is minus this height and divide that by 7 minus 2, which is just 5. So that's basically, to write it in terms of math, that would be x of 7 minus x of 2 divided by 7 minus 2. That would be your v average. Okay?
Back to the acceleration, you said it was the slope. Would it not be -1?
The slope for this one?
Yeah.
The slope looks like +1 to me.
Oh, because I thought it was like -2 over 2.
Yeah, so you've got it backwards. So this is basically this is velocity versus time, right? So what we're looking for is velocity at 2 minus velocity of 0 over 2 minus 0. And velocity at 2 is 0. Velocity at velocity at 0 is -2. You see this? This is how you get 2 over 2. Yeah, so it's a good and informative question. But don't get confused by the fact that it's starting at a negative number and going to positive. You know, that ultimately the sign of the slope here is going to be positive. You can do a sanity check by just like looking which way it goes upwards. Or if you want to do it math-wise, just be very careful that you've got the order right. It's final minus initial. Okay. So the next one is asking about displacement. Now we have to get into area under the graph. Between 0 and 4 seconds. I don't know why I keep redrawing this. It's the same thing every time. But if this is velocity and this is -2 and this goes up to 2, what is the displacement between 0 and 4 seconds? So what we kind of have to do here is we kind of have to draw a, what do you call it? Like, we have to just draw, well, I would suggest drawing the 0 line. Let me draw it a little bit more symmetrically to kind of give us an idea of what the sort of calibration point is, what the sort of, you know, just visually let us know where 0 is in the graph. But the idea here is that displacement, you can get displacement from a velocity graph by looking at the area under the curve. So the idea here is, in this phase, when the velocity is negative, it's sort of moving to the left. And in this phase, it's moving to the right. And it turns out these areas are totally equal. You should be able to see that just from the symmetry of the situation. But if you wanted to explicitly calculate it out, sorry, I didn't draw this very nicely. If you wanted to explicitly, you know, calculate the area of the triangle, that's fine too. But you should be able to see that the displacement is equal to 0. Because the positive area and the negative... So the area... Excuse me, you could kind of think of this as negative area, almost. Because this is contributing towards movement towards the left. And you can kind of think of this as positive area. Oops. You can kind of think of this part as positive area because it contributes towards displacement to the right. So the net displacement is 0. And what this looks like on the number line is basically it's moving to the left, moving to the left, moving to the left, and it's kind of, you know, it's kind of speed is going to 0, and then it starts moving back towards the right until it ends up at 0. You see that? Does that make sense? That's for
Yeah.
question 6. Good. Yeah. Question 7. It's yeah. None of these seem to involve any systems of equations, so maybe you guys will luck out. But a car starts from rest and drives with acceleration of 2 meters per second, so that's the initial acceleration. And when it reaches a speed of 20 meters a second, so I guess we'll call this, you know, I don't know, velocity 2 maybe. So then the car slows down with acceleration -1 until it stops. What is the time spent for the entire trip? Okay, so one of the things about this question is that it doesn't even ask about distance. So we can basically stick entirely to the kinematic equation of Vf minus V naught is equal to AT. We don't even have to use the ones that involve distance. So let's draw out what's happening, right? It's basically saying it's at rest at first, and then it starts picking up speed, picking up speed, picking up speed. So its acceleration is equal to 2 until at this point where it says velocity is equal to 20 meters a second. At which point it sort of starts to peter down, brake, slow down until it stops. Right? So basically, I just want to figure out how long this period takes. So what is, the first change in time, and then what's the second change in time? So I guess the acceleration here is equal to -1. And yeah, to do that, let's say for the first, for the first phase, it's 20 meters a second minus 0 meters a second is equal to 2 meters a second squared times whatever t is. Maybe I'll call this t delta t1 to represent the first phase. So to do this, okay, that's just 20 divided by 2, so 10 is equal to the time for the first phase. Okay, so that's 10 seconds. And then the second phase is basically very similar, but it's saying velocity final is going to be 0 because it's, coming back to rest at the very end. And that's minus whatever the velocity at the sort of changing point was, which was 20. And that's going to be equal to a deceleration of -1 times the second change in time. So at this point, you can see that delta t2 is just going to be equal to 20 seconds. So together, these add up to 30 seconds. Yeah? Sound good?
Sounds good to me.
And then the last one is you run to class to make it on time for lecture. So what have we got? We've got 1 mile from your dorms. You run at the speed of 4 miles per hour. The class lasts 1.5 hours. Afterwards, you go straight back to your dorm. However, you are tired. What is your average speed during the time interval when you left the dorm and came back? Oh, interesting. Okay. So that's basically saying, I don't know, maybe this is your home and this is your dorm. So it's what? You basically have to figure out if you're going 4 kilometers per hour. 4 miles per hour for 1 mile. That's basically 0.25 hours at 4 miles an hour, right? And then class lasts an hour and a half, okay? And then you come backwards at 2 miles an hour for a mile. So that's basically 0.5 hours at 2 miles an hour. Okay, so then we just basically add up our time, right? So this is, I'll just write out explicitly. When you're in class, that's 0 hours. That's 1.5 hours at 0 miles per hour. And notice that it's asking for speed, not displacement or average velocity. It's asking about average speed, which means that you treat all of these as, you treat 4 miles per hour and 2 miles per hour both as positive, because we're asked about speed, which is magnitude, right? So even though the velocities are in different directions, we're only asked about magnitude. So to do this, we basically just add this all up and divide by the total time. So we just do 0.25 times 4 plus 1.5 times 0. plus 0.5 times 2. And we have to divide that all by 0.25 plus 1.5 plus 0.5. And just whatever that is, which I think is 2 over 2.25. It's not the nicest number in the world, but it seems to be about what it is. Maybe I made a small mistake somewhere.
It's correct.
It's correct?
Yeah.
That's weird
You just
because you're being asked
I
for
guess
1 sig fig, which you can't really represent.
0.9. Could you like make that to a decimal?
Oh, wait, what is this? Is this 8/9? 0.888 or something? Something like that?
0. Let me check. It was 0.9. So you just run that off, I guess.
Sure, okay. Why not? Yeah, so that's basically it. All right, so for this problem, just the idea here was to do a weighted average of whatever your speed is. You just have to multiply your speed at each phase times the time spent in that phase. And that's all there is to it. Yeah? Any other questions? Was it illuminating?
Did you guys go over the graph?
We did. We
Can you
there will be
scroll up,
sure.
please?
There's also recordings which I will
Oh,
link to.
okay. I had a question. Like, it asks you for velocity and acceleration. Acceleration is the slope of the velocity time graph, right?
Yes.
So, but how do you find the velocity
How do you
of the
find the
velocity
velocity?
time graph between 2 points?
You're talking about part 4, was it?
I think so.
Yeah, so it was asking for average velocity between times 3 and 4.
So
So to
do you
do
just
that,
take the slope?
no, you take the average of the points. This strikes me as a little bit odd because someone else had the exact same question or misconception. But if you're looking for the
Yeah.
average velocity, what happens? Yeah, what is this? So
can you also? Oh, sorry.
yeah, so let me show you the difference between getting the slope and mathematically versus getting the average, right? So v at 2 plus v at 1 over 4 minus, sorry, what did I say? I should say v at 4 plus v at 3 over 4 minus 3 is going to be equal to 3. Sorry, how did I fuck this up?
Can't you also find the displacement using the graph and then divide it by the time?
Yeah, you could do that. Sorry, why am I having a brain fart here? What am I doing wrong here? The average here is clearly just 1.5.
Mhm. Isn't it just 2
divided by
plus
2.
1 divided by 2?
Yeah, it is. I don't know why I'm saying 4 minus
Yeah.
3 on the bottom. It should just be divided by 2 to represent that there are 2 points. But then so this is the average, and then there's the slope, which is v of 4 minus v of 3 divided by 4 minus 3. That's why I was getting mixed up.
So for
So-
the average, you just don't take into account time, right?
Yeah, I guess that's a good way of saying it. Because the acceleration is constant, it turns out that the average, you can just look at the start and the end point without having to worry about time.
All right, thank you.
Yeah. Very silly of me.
So-
What was I
So
doing
to
there?
get the average velocity, you just get the time in 2.
I'm sorry?
To get the average velocity, you just divide the time.
Yeah, not the average velocity, you don't divide the time, you divide by just the fact that there are 2 points. The beginning and the end. Right? Whatever the person was saying before was sorry, why am I getting all mixed up today? Once you learn how to do calculus, yeah, this turns into integrating over this interval and then dividing by the time. But for the purposes of non-calculus, in average, you can just think of the initial and final and divide that by 2. Sorry.
How did you get 1.5?
I'm sorry, how did I get 1.5?
Yeah.
That's just 2 plus 1 over 2. right? I think the fact that you've all recently learned calculus and learned how to get and learned that acceleration is just the derivative of velocity is tripping you all up, because this is a question that you could have answered from high school without presumably without even learning physics. It's just asking for the average between 2 points, right? Or the average between a velocity of 1 and a velocity of 2 over a period, which is just going to be 1.5. Does that make sense?
Yeah. I also have a question. Can you go back to number 3,
Sure. What's up?
please? Just wanted to look at it. I didn't understand it.
Sure. I have a recording of this as well that I can put up. But the general idea here was to figure out the actual weight of each component at the start, which if they had 14,000 kilograms of 0.8 and 0.2 mixture, just multiply that out. So that's 1120 and 280. And the idea here is for the sand, it's going to be 1120 is the sand, and you're not adding any more sand. So the numerator is just 1120, and the denominator is 1400 plus x, the amount of cement to be added. And we're trying to make this ratio equal 0.7, which is the ratio of sand in final mixture. So then once you have this, you can just solve for x, and that's how much cement you need to add. That's all.